Okay. Good afternoon, everyone. I hope you all are doing well. Welcome to session 4 of the Bibliometric Manuscript Writing Program that is on data collection and management for bibliometric analysis. We are excited to have you all here for this important session where we will explore techniques and tools for collecting and managing data in bibliometric analysis. So today's session will be taken by three different mentors in three parts. Um, Dr. Priyadarshini B, Ms. Pragyan Mona Lisa, and Dr. Amit Vasant Mahuli will take the three sessions. So before going to start this session, I would like to give a brief welcome by Professor Sonu. Over to you, sir.
Thank you, Dr. Ravita. So, first of all, welcome to this week of our bibliometric analysis program. So, as you know, that all of these sessions have been kept in mind, considering the fact that all are very important for writing your paper, your manuscript, right? So, in case you miss any session, try to see the recording, because without seeing the recording, it will be very difficult for you to actually go through what actually transpired, and you will not be able to write effectively that particular section. So I request all of you to join live. That is number one. But in case in one or two sessions you are not able because of your schedule, please see the recording thoroughly. So this is number one. Number two is I have seen that many of you have submitted are submitting your part of manuscript based on the timelines. But there are few of you who have not submitted that part, because I guess we have written up to introduction. So that introduction section need to be added in your folder, in your Google folder. So we will be sharing, we have shared with you the status, and we will be sharing that status with you. But please follow that, because in case we find that some team has been delayed a lot, like we have reached up to discussion, but we have not got introduction. So we may consider that team not to be a part of that particular program, because we will consider that that team is not very serious, and that will be detrimental to this program. So I request all of you to get back with your respective sections in time, after due consultation with your mentors, right? And number three is your regular meetings. So I hope that every one of you have made meeting schedule, like every 15 days at least. You should have a meeting, and we have a meeting calendar which have been shared by mentors. So they will be writing those whether the meeting has been conducted for that particular team in 15 days, and we will be continuously monitoring that calendar, because that will show that again the team is relatively serious in writing manuscript. Why we are considering these type of checks and balances? Because we have seen that those people in past who have adhered to the schedule, so have fared very well. So they have published in very good journals, and those who could not meet the timelines, were not able to publish in that good journals, or were not able to publish that. Like, so please keep in mind these three things. So that's why I've come to just tell you about these three very important things, right? Or in case of any clarification, doubts, Dr. Ravita is there. So I think you have your groups as well. In your WhatsApp group, please tell, and Dr. Ravita will convey. And in case he fails to solve anything, so I'll be there to do that. Dr. Ravita will discuss with me those queries. Great. So thank you, all of you, and I welcome all our three facilitators uh, uh, who have made efforts in making that good presentations, and also the presenting those presentations. So Dr. Amit
Thank you,
is
sir.
here. Welcome, Dr. Amit.
Thank you, sir. Thank you for your
Yeah,
kind words.
Dr. Priyadarshini is there. And who is there next?
Mona Lisa.
Dr.
Miss Sahu, Miss Sahu.
Dr. Sahu is there, right? Yeah. So great. So yeah, please go ahead. I think with the next one, Dr. Avita, over to you.
Thank you so much, sir. I'd like to welcome all the three mentors. So, the first session will be taken by Dr. Priyadarshini, that is on data collection and management for bibliometric analysis. And in her part, she'll focus on how to select appropriate keywords, use of Boolean operators and their combinations, various databases that can be utilized for bibliometric research. So before going to start, I'd like to introduce Dr. Priyadarshini. She's currently assistant professor in Vellore Institute of Technology. Uh, she has done her PhD from IIT Kharagpur. Her key skills are in environmental epidemiology, biostatistics, and environmental exposure. Her publications are in peer-reviewed publications in international journals and national journals. So I would like to welcome Dr. Priyadarshini. Ma'am, please, the stage is yours, and now you can start your part.
Thank you, Dr. Ravita. Good afternoon, all. So, this is session 4, and today we are going to focus on data collection and management for bibliometric analysis. So, in this session, I'll be having a brief about. So, these are the contents of today's session. We are going to see how we are going to how we are supposed to choose keywords for searching in databases, how to use mesh terms, what mesh terms means, what are Boolean operators, their combinations, and also various databases. And in this final part, or in the third one, I'll be taking you to Scopus and also PubMed and show you how to use it and how to take data from both these databases. So this is a brief about today's session. So, first of all, before going to the session, I just want the audience to answer me. What do you think is the purpose of a keyword? Can anyone unmute and answer?
uh, to select appropriate data, to get the required data.
Okay, to select appropriate data. So here I have put up a lot of pictures, like you have Bibliometrics, you have Vivo's Viewer. These are all tools which is used for doing bibliometric analysis. You can use any of these tools. But what we need to understand is these are tools, and these tools specifically will work based on the input which we are giving. So whatever output we are going to get from these tools, and whatever output we are going to present based on the questions we have chosen, research questions, that is entirely based on the input. So that input, whatever we are giving, that is connected with the keywords. So that brings us to fact of what are keywords. Most of you by now have used various search engine, starting from Google to other search engines. So when we are talking about keywords, these keywords, they actually work as either as a word or in combination of 2 3 words to get us to relevant search papers which we want, right? So if you're all aware of a manuscript and articles, you're writing articles as a part of this program, and we see that we give certain keywords. So this keywords serves as a path to reach our paper in any of the database. It can be Google, it can be Scopus, or it can be any of the search engine. So we have medical or mesh terms as well, which are medical subject headings. These are otherwise called as technical terms or jargons, which are used by medical professionals. And these are keywords which are indexed in the National Library of Medicine, right? These are all indexed. So if we use appropriate mesh term, that is going to bring us relevant literature which we want. So the first set of keywords usually every researcher uses, from whichever subject he can be, maybe from policy, he can be from engineering, or he can be a statistician as well. But if you're taking medical subject heading, these are relevant only to doctors or epidemiologists or anybody who are working with health oriented research. So when we are talking about keywords, we can use any keyword or any word which we want to search for a relevant material which we want, right? But the difference between using generalized keywords versus specific keywords, that brings us, or that will put you into a major difference of bringing manageable set of results which we want. Otherwise, generally when you go to Google is a search engine, and you're going to try different set of keywords. You're going to write what is the temperature of so and so place. So it's going to take each and every word, it's going to assume as a keyword, and it's going to go and search. It can have millions and millions of documents, and based on the words which you have typed, irrespective of small letters or capitalized words, it's going to bring you the relevant answer. So anytime you search in Google, you're going to have in this many seconds, this many number of results, which means for whichever words you have used, you're getting millions and millions of things. But when we are talking about research, see, we don't have so much of time to go through almost all the results, right? That is why it's very important to use specific keywords. So when we are talking about keywords, there can be a question of how can I choose a keyword? Can I keep it random? Can I keep a random research question? And can I choose any keywords and search a set of articles? And can I proceed? Or does it have a strategy to do it? So there is a strategy to do it. And that strategy is mapping your research ideas. So until this point of time, in this specific workshop, you have all given your research questions, right? And that research question, those are the questions which you thought it's very relevant, or you're interested in that research, or you know something about the research. If not, what is the appropriate way to map your research ideas? So when we are talking about research, right? So I work on air pollution, how to measure air pollution, what are the different set of instruments, satellites, and currently I've started working on air pollution and health. So this is something which is very, very general. There's no research question as of now. So when I'm talking about generalized mapping, if I want to map my research question, I would take a piece of paper, or also there are various tools through which you can actually do a mapping. So I will write, okay, air pollution and health. So what are the different health outcomes which I know or which is there on Google related to air pollution? Cancer is very, very well known. Respiratory disease is very well known. Lung cancer, yes. Maternal health is one of the emerging topic because the biological aspects of it is not well explored. Neurological and mental health and others like cardiovascular disease and other things, there are evidences related to it. So first of all, I will list anything which is oriented with air pollution and health impacts. It can be, I have only listed 6 to 7 over here, but it can be more than that as well. So I have to narrow down. Now I have to choose what I want to choose. Like I can write a question. I'm interested in maternal health. So I'm writing something, right? How does air pollution affect maternal health? Okay, does it really affect maternal health? Or how does the exposure happen? So this pregnant women, are they being exposed at home, or are they exposed outside, or are they exposed in an occupational setting? Where are they exposed, right? And also, there can be n number of other questions. The other question can be during which part of pregnancy they are affected. Is it their first trimester, or the second, or the third? So I can write. So now I have a set of questions where from a very generalized topic, I had narrowed it down to a certain question. So now at this point, I can go and search each of these questions and check how many number of articles I have, or I can further narrow it down to formulate a research question. So now here I'm really interested in knowing where does this exposure happen. We all know that two-thirds of the time we spent at home. So the exposure mostly what a pregnant woman is exposed is mostly at home. If my hypothesis is that I have to write what are the different exposure they can have. So ambient is surrounding air pollution, which is outside. Household is because of air pollution, which is coming from the household. And the other one is indoor, whichever is there inside the house. The second one is oriented towards cooking, cleaning, and other things, right? So from here, I can formulate a question of what are the pregnancy outcomes associated with household air pollution. You have to note here that this concept map can be a rigorous process. Here, just to accommodate and give you all an example, I have kept it very simple. So you might all wonder what is the point of this research question. So the keyword which I spoke in my previous slide from this research question is where we are generating our keywords for a search to find out articles which can be relevant to your bibliometric analysis, right? So we come to the generation of keywords. So when we are talking about generation of keywords, I have my research question which is highlighted over here. What are the pregnancy outcomes associated with household air pollution? Now, I can take off all the words which are very common. What are the, that doesn't make any sense, right? So I am taking pregnancy outcome over here, which is highlighted, and also household air pollution. So the first and foremost thing, what we are supposed to do is find out the synonyms of the words, the keywords which I have chosen over here, because we might know only a certain synonym for a keyword, but there can be n number of other combinations which can be out there. If you are an expert in your field, maybe you might know all the keywords, or you can take help from the articles, what kind of keywords they have used. Otherwise, it's always better to find out the synonyms of the keywords. If at all you are a tech freak, you can always use the help of AI to ask alternate synonyms for this keywords. It's going to give you alternate synonyms. So list out what all can be alternatives of pregnancy outcome: reproductive outcome, birth outcome, prenatal outcome, maternal outcome, etc. So, household air pollution can also be called as some people also use indoor air pollution, domestic air pollution, residential air pollution. It can also be like cooking. So, from cooking, also different kind of pollutants can emerge. So, knowing this is what is very essential for going and searching or using these keywords on Scopus or Web of Science, etc. Right? So if I have to keep my search very, very broad, then I can have combinations of this keyword with any one in the second category. So let's keep, I want to find what is the impact of household air pollution on pregnancy outcome. So I can categorize one pregnancy outcome as category one, and the second one, which is on pollution, as category two. I will go on searching maternal health, and air pollution, or I can have combinations of all these things and also the second category, and I'll keep searching. So when I am going to search this one, if I'm going to get more than lakh or 2 lakh papers, that is very difficult for me, right? In that case, I need to narrow it down. So how can I narrow it down? I can have a certain component of that keyword and I can narrow it down. For instance, maybe I'm only interested in the birth weight of a child which is born. Okay, so I want to find what is the impact of household air pollution on birth weight. It's one of the pregnancy outcome, right? So I can narrow it down by searching this category which is given over here with the other set of keywords which are given. So this is the first exercise which you can do or which you can play around to check how many papers are there in your field. Because if you're going to have a huge set of articles at your hand, it's very, very difficult to produce some meaningful maps which you can make through bibliometric analysis, right? It's going to be very congested. It's not going to be visually, it's not going to be appealing. And also for the reader, the kind of takeaways he would be taking from it, it would be very, very clumsy, right? I hope you're all clear with this. So after generation of keywords, we have something called as Boolean operators. This is something which we use in day-to-day life in search engines like Google. You are combining with and or and not. So these are Boolean operators. So this Boolean operators is going to refine a search result. So whatever we are searching in a database or a search engine, so these Boolean operators are useful for search engine optimization. Search engine optimization means that you are making your search optimized. You're making it better by using these operators. So the first one is using and. So we have a specific set of keywords. For example, I want to know how many papers are there, or how many papers are worked. What is the impact of climate change on agriculture, right? So if I use this keywords called climate change and agriculture in any normal search engine, it's going to bring documents whichever has the word climate change in it, climate in it, and also agriculture, right? But that's not what I'm looking for. I'm looking for papers who have combinedly worked with climate change and agriculture. So if I use this Boolean operator and over here, it's going to combine climate change and agriculture, and this intersection which is there, the papers which have used both climate change and agriculture, that is going to come to me. So if you're just playing on Google or any other search engine, right, you can just check with and how many, how many papers you're getting, or by using separate keywords, how many papers you're getting. So in some instances, what can happen is that, as I told, keywords can have synonyms, right? See, global warming is a subset of climate change in itself. So climate change refers to either warming, or it can also be cooling of the Earth's temperature. So now I want papers which have the words called as climate change or global warming. So I'm going to specify in the search engine that bring me papers either with a name climate change or global warming and agriculture. I can combine. I can use either one Boolean operator or I can use more than one Boolean operator, right? That is how I can actually make my search very, very simpler. Now you have other thing. The other thing is, suppose you have a certain, you are an expert in your field, you know a certain keyword, you don't want that keyword, you want specifically a certain terminology. Okay. So here again, I can even take climate change or global warming. I'm going to say climate change and not global warming. When I specify that, it's going to bring papers which are relevant only to climate change and not global warming, because I'm not interested in global warming. I'm only going to do research on climate change in itself. I'm just excluding, maybe in exclusion criteria, I'm going to write, no, I'm not taking papers which are on global warming. I'm taking both the effects, right? So your Boolean operator is used to refine your search. And it's not only on Scopus, it's on Google. You have more operators like plus or minus sign. There are so many different things, but I'm keeping it in context that for Scopus, we are going to have and, or, and not for PubMed and other search engines as well. So we have different databases from which we can get the data by using specific keywords and also the Boolean operators. We have Scopus, we have Web of Science, we have Google Scholar, and also we have PubMed. So what are the difference between all these databases? By now from session 1 to 3, you must have had a glimpse or a thorough knowledge of what it is. But to the context of what I'm speaking over here, we have all these databases: Scopus, Web of Science, PubMed, Google Scholar, you have Dimensions and Lens.org. So when you're talking about Scopus, Web of Science, These have highly indexed, you have journals, you have book chapters, you have letters to the editors, you have notes, you have different things which are indexed as a part of Scopus and Web of Science. And specifically, when you're talking in the academic context, both Scopus and Web of Science in indexed journals are only welcome, because it all these journals are peer reviewed. But the limitation of both these databases, that it requires a subscription. Only institutions which have subscribed to this, they only can access Scopus and Web of Science. But both these platforms, they give really, really good, all the journals and all the books and other things which are out there. So PubMed, it covers all biomedical and life sciences, and specifically the medical terminology, which I was talking on my first slide. All those things can be used over here, because that is also indexed over here. And when compared to Scopus and Web of Science, PubMed is it's open, it's free for all, and it's highly used by health and biomedical research professionals. And we have Google Scholar over here. When compared to these three databases, Google Scholar, it's going to have almost all things. You have books, you have papers, you have conference proceedings. When compared to Scopus, Web of Science, and other things in Google Scholar, manually you can add whatever you have published. It's also going to have gray literature, which means it can have anything and everything, right from notes to all the other things. So now, when compared to other three databases, here you're going to have humongous amount of material, and that's very, very difficult to screen and to analyze. But for a very, very quick search of certain literature, you can always use Google Scholar, and it's easily available, and also many people used to use Google, so it's pretty much easier, right? And the other two databases, this is not part of my talk today. I would be teaching you a hands-on of how to use Scopus and PubMed today. Though most of you must be aware of PubMed, I specifically like using Scopus because it's user-friendly, and also it's pretty much easier to use as well, right? Till now, do you all have any doubts? If you do not have, I can go and teach you some more, some more shortcuts to use on Scopus. Then I can open Scopus and also PubMed and teach you how to use those keywords, how to, download the data and other things. Do you
Madam,
have
what
any
is,
questions?
excuse me, ma'am.
Yes, sir.
Hello, can you hear? So what is bibliometrics and his site and all? Which one you showed in the beginning? What are they actually? Bibliometrics, when you were showing on the
Okay.
first slide.
Okay, the first slide. Sir, for conducting your bibliometric analysis, right? These are the different tools which can be used, right? Bibliometrics is it's using a R software. You do not have to know to code, but just there is a one line where you will be calling the library, and this opens like a tab where you can give the list of papers which you're downloading from Scopus or PubMed. Vivo's viewer is also again a tool. These are all different tools, right? So
Okay.
here, what I told is that we are giving a set of papers as input to all these tools, right? So basically, these are tools. The tools doesn't know what you're giving is fine for it or not. Whatever you're going to give it as input, it's going to produce an output out of it, right? So your keyword is the basis that you don't leave any of the papers. You don't love because you have not used a certain keyword, you have missed a couple of papers. That should not happen, right? So to ensure that your input is good to go, your keywords are essential. So these are different tools, sir.
Okay, thank you, ma'am. Thank you, ma'am.
Okay. So I'm going to show you a little bit of tricks and general tips which are available on Scopus as well. So the first one is loose phrases versus separate words. So whenever we are searching, see, by now most of your doctors who are attending this workshop, I'm pretty sure that you know how to use keywords, but certain tricks can help you to bring better papers out there. So loose phrases versus separate words. When it comes to it, so again, I'm having an example of climate change, right? So if I'm going to give it as climate change in itself, the database would take it as climate and change separately. Okay, so it's going to bring all the papers which are there on, which have used the word climate and also change in any of the title, abstract, or either keyword. So it will add a Boolean operator and by default by itself. Even you don't give it, if you're not going to put it in double quotes, it's going to take it like that, right? So in certain aspects, if you are very, very sure about your keywords, right, either using a double quote would bring you climate change as it is, or if you're very sure about your keywords, you can always use a curly brackets. So where can we use this curly brackets? So you can use curly brackets when there are accented characters. For example, maybe our my research does not have any specific pronunciation associated with it, like a Spanish or French term, which is there out there. But certain research can have certain terms, which is of French, Greek origin, or it can have Latin symbols. So in that case, using a curly bracket would ensure that whatever is inside the bracket stays as it is. Okay. So, and there is something called as lemmatization. What it means is that right now all our AI use natural language processing. Natural language processing in the sense that whatever you're trying to search, it can bring it back to its original meaning, the broader aspect of it, right? It can be computerization, it will bring it to computer because the base word is computer over here. So what's the difference between a quotation mark and a curly bracket? Quotation marks, most of you know. Even in Google, if you want a specific thing as it is, you can always go for quotation marks. So when you're using quotation marks, it is much flexible compared to curly brackets because your quotation marks is flexible because it can consider variation of a spelling or it can consider variation of what you're searching. But if you're putting curly brackets, it is less flexible. Whatever you have typed inside that curly bracket, maybe with an hyphen or without an hyphen, it's going to, with a hyphen or without hyphen, it's going to bring it as it is. So you also have to note when you're typing certain keywords, right? Certain sentence, certain words can be compound sentence. It can have a hyphen. Some authors could have given it without a hyphen. You have to consider both the variations. Otherwise, you might miss certain papers which is with hyphen, right? And also, when you're talking about precision between quotation marks versus curly brackets, the precision of the curly brackets are very, very good. So now what happens? See, if I'm going to be, I am doing search with Scopus for a pretty longer time, right? I mostly use curly brackets because when the number of papers that's going to cut down when I'm going to use a curly bracket, if I'm going to just use climate change versus climate change with quotation versus climate change within curly brackets, right? The number of papers are massively going to cut down. You can also go and have a try. We'll do it and I'll show this. Then your default search strategy always has to be title, abstract, and keyword. In when you're going on Scopus, right? In PubMed, it only takes all fields or it has certain options to it. So what it means is that as an author, when we are writing paper, we always have to remember that if you want visibility to your paper, you need to add that specific keyword either in the title or it should appear in an abstract or it should be in the keyword. So your abstract is generally the synopsis of your whole work, right? Like what's a background, what's a methodology, what did you get, and where it can be used. This is what your abstract is. Now, what happens is when you take climate change, since this word is like a hotspot topic, right? It's everywhere. Now, certain times what happens is this climate change would not be in title. They must not have worked on climate change, or it's not enlisted in the keyword also. But the author would have used climate change as one of his or her last lines in an abstract. But the work is not relevant to climate change at all. So, if you are giving a keyword, suppose the keyword is appearing in all the three title, abstract, and keyword. Great, the work is directly relevant. Why? Because it's appearing in all the three things. Even if it is appearing in title and abstract, great. Okay. So, as an author, what we have to do is, if your paper has to have visibility, you should use appropriate keywords so that even in Google or any search engine database, someone is going to put the keyword, your paper should appear. Okay. And there is something called as proximity operators. This, in most cases, not many people will use it, but otherwise, there is something called as preceding backslash n. What it means is that suppose if I'm going to use a word called a search called Zika virus, right? So some people would have used Zika and dengue fever. Okay, so they have used combination of both these things. So I'm trying to say preceding slash two words or three words, which means make the first word be present within two words of the second word, which is like a virus or something like that. So when you're using within slash n, it doesn't matter whether the first word should be in the first or second. Somewhere within this first two words or three words, make this word appear. So both is proximity operators. You can also use it on Google for your search, not only on Scopus. So finally, we have wildcards. Wildcards means suppose you are typing, you are not sure of the spelling, because in certain cases, what happens is modeling. Modeling has a single L in US spelling. Modeling has a double L in European spelling, right? So maybe at times, if you're only going to use modeling with a single L, see, in most of the cases, Scopus has the AI right now. It's going to give you both the options, but in some cases, some databases would not bring certain papers. So what can happen is we can put a like question mark in between MODE, where L is there, you can put a question mark continued with the spelling. So by itself, it can fill that spelling and it can go and do a search for you. Then finally, you have an asterisk. So what it means is that certain things can have a lot of combinations, right? It can be like air pollution, air pollutants. So there is a combination of pollution also, pollutants also. So after a certain point, pollutant, POLLUT, then I'm going to put a asterisk mark. So what it means is that I am telling the search engine database that you take combinations of whatever comes after T and bring me the papers which have utilized this keyword. So this is a very, very generalized tip over here. Until this point, if you have any doubt, please let me know. Otherwise, I'll go to Scopus and PubMed and I'll show you how to do search, how to analyze the papers what you've got. Do you have any questions?
Madam, good afternoon, ma'am. Hello. Hello.
Yes. Please go
Ma'am,
ahead.
myself Raj Lakshmi. So if there is a synonyms, two or three synonyms in a keyword, so we have to mention all the synonyms with R. Is it right, ma'am?
Yeah. Yeah, you're right.
All the synonyms we have to mention with R, and if there is a combination, like you said, birth weight or anything, we have to mention the add end.
Yeah. So why we have to do that is certain people would have used as reproductive outcomes, certain people would have only used as prenatal outcomes. So we
Yes.
don't want to lose papers which have used that certain, but all these things are only meaning what we wanted to search here, right? We want to search on pregnancy
Yes,
outcomes, and these are synonyms, so we don't miss out. In certain cases, what will happen is when you put reproductive outcome, also papers might come. Okay. So when we are going into Scopus, I will show what author and index keywords means. And because we might give certain keywords, but then Scopus also will go and place our papers using certain index. Okay, there maybe reproductive outcome can come and a paper can come. Otherwise, we might miss out papers. So mostly researchers, when they are writing review papers, right, we tend to give the search strategy over there. What are the keywords which we have used? We are giving it because if some other person is trying to search with the same keyword, he should also get moreover the same number of search results. Okay. Because the other author, maybe certain times a review paper can come, they could have missed your paper just because they did not use an appropriate keyword or they missed a keyword there.
Thank you.
Okay. So we'll go to Scopus right now, and I'll just we'll have a quick glance of both Scopus and PubMed. Okay. Scopus needs subscription. So people who are having Scopus, it would be good to learn this. People who do not have Scopus, still it is good to learn, because down the line, someday, if you're having access to Scopus or you're asking your friend to do a search for you, you should know how to use Scopus, right? So of course, this is how Scopus looks like. So you are having all the fields, article title, abstract and keywords. You have authors, you have n number of other things, keywords and other things, right? So for getting relevant papers, it is always good to go with this combo of article title, abstract and keywords. So what you're telling to the database is, whatever keyword I am searching, please go and check if it is present in article title, abstract or keyword, right? So you can choose this one. Now, what I have done is the same example which I have shown you in my presentation. I have categorized them into two things. What are the two things? The first thing what I have taken is the reproductive outcome. Okay. So I'm using a curly bracket over here because that is going to narrow down my search, and the number of papers which I'm going to get is pretty much less. That's the reason I'm using it. So I am using a Boolean operator over here. As a beginner, most of the cases, what you might do is, you can always go and add a search field over here and choose the Boolean operator over here, whether you want and or and not. I don't want to do that because that is going to have my search. I'm going to have a lot of search boxes over here. So that's the reason I categorized into reproductive outcomes. So I give all the synonyms of reproductive outcomes which I showed you in the slide. I have separated all of them by I separated them by or. Okay. So you have to be very sure about it. Even if you're missing one curly bracket over here, it's going to say syntax error, because that's the language, the whatever you're giving over here, that's a syntax. You're talking in terms of a computer language. what it can understand and saying, go and search any one of these keywords. If this is either bring 2, 3, whatever is there, please bring it. If they are present in article, title, abstract, and keywords. There's a second one, second category I kept entirely related to pollution. Okay. So now what you have to understand is it is not always necessary that you should only have two categories. Suppose for this particular search, I have 73 documents. All right. What if I have 1,000 documents, 2,000 documents? I can't able to complete that research in a stipulated time, right? You are time bound. So you have to narrow your research question and you need to present to your audience. So here I can have a third category. Maybe I can tell South Asia, or I can be country specific, or I can be, see, because my research question, I can't be age specific over here because already it's only pregnant women. So it is going to, it's a very gender bias, right? It's only women who can be pregnant. Obviously, I can't take men over here. But otherwise, if I'm going to have other outcome, what about diabetes? If I'm having a diabetics, then I can go as I can give adult, or I can give a certain age group. Then I can also narrow down my search. So it's always not that it should be only two categories. It can be more than two or three, depending upon what how much you want to search and how much of time you have, right? So whenever you're searching on Scopus, the greatest deal is that today, as of today, I want to save my search, right? Whatever I've searched, I don't want to type this keywords again and again. I don't want to type. If I want, I can always add whatever I want over here. Otherwise, I can go to the left hand side. So you can see as save search, right? So I can save my search as, I can give a certain name, whatever name I want, reproductive outcome, whatever, and today's date. So I am going to have this search in my saved searches. And anytime I'm going to click that save searches. So I can show you over here. See, I'm going to save searches. Okay. So under this profile, I'm going to have save searches. So when I come to save searches, I think there's an issue. Okay. So under save searches, I'm going to have whatever I have saved right now, that will be there. So you can see this is what I've searched, right? Then I can go to this results and I can check out any day. So if at all after 5-10 days, if the search results are going to have some more papers, you can check over here. What if I want to do a bibliometric analysis and I want to freeze the data over here, right? Because most of the times when you write a bibliometric analysis, you write the search, we have taken papers right from so and so year until a certain date, 25th of November 2024. In that case, you can actually save the list. You can choose all, go over here, and you can actually save it as a list. So the difference between saving a search versus saving a list is that when you save it as a search, any day you can keep searching and the papers can keep adding. But when you're saving it as a list, right? When you can save it as a list with a search, however you want, you can save it. And when you save it, it is that the number of papers what you're seeing today, that's the number you're going to have it always, right? And whenever you're going to Scopus, Scopus is a great platform, as I say. So why? When you're doing bibliometric here, I'm having 601 documents, right? Because the search has changed over here. Because as it refreshed, I think it has changed. Otherwise, I can add a household air pollution. So can you see how much I have cut down? See, because in my previous search, which at the beginning of the Scopus, I had showed alternative to it. But right now, as you can see that I had just narrowed it down. I only have 29 documents. If you're going to do a systematic review, in that case, this is going to be pretty much helpful to you, right? So as you all know, in your left hand side, you're going to have the range of from when to from which year this research has started. So whatever you're doing in your bibliometric visualization, right, from when this research topic has been in place, how many papers has been published each year, that you're getting in Scopus also. Even in PubMed, you get it. So as the year progresses, you can see in 2023, so many papers have been published. Which all subject area this kind of research are being published: environmental science, medicine, toxicology, energy. Why energy? Because for the production of energy, so much of air pollution is being produced. So people from energy discipline also, they are producing this kind of papers. And I only have like 2 articles and 25 articles review. I have to suppose if you're combining bibliometric analysis with a systematic review, you have to check whether somebody has a systematic review in place. Then you can always see over here. So, for instance, I was talking about, so I've given this keyword, right? See, reproductive outcomes, alternatives of reproductive outcomes on household air pollution. So what I'm seeing over here is in the very first itself, it has highlighted household air pollution. Household air pollution is there. Okay. But this is not talking anything relevant to a reproductive outcome, but somehow still stillbirth is there because this person's either in their keyword or somewhere this reproductive outcome or something should be there. So if I'm going to click this document, right? So you come to this document. So this author keyword are the ones which you are choosing. You see that in the title and also in the abstract, reproductive outcome was not there, but household air pollution was there. But birth outcome is listed over here, or neonatal, some neonatal, this word also, I guess, natal, prenatal, I had used. So somewhere this author keywords are the ones which we are choosing. And there is something called as indexed keywords. So here in indexed keywords, maybe I guess this paper is produced by doctors because mesh terms are also given. Not all the papers would have mesh terms. You have other terms, other medical terms under which this paper is listed, which means if you are giving any of these keyword combinations over here in Scopus, you're going to have this paper on your search database. That is what it means. So also other thing is when you're doing bibliometric analysis, right? You would be producing connections between keywords, between authors and all, right? So when you're choosing to produce connections between keywords, there is an option to use whether author relevant keywords or all keywords. So when you give author relevant keywords, these are the keywords. So here we are only seeing one paper. Now for your bibliometric analysis, you might use 60 papers. Those 60 papers might have 10 keywords or 7 keywords. So you would be having 420 keywords. Suppose if you're giving all keywords, it means that it's going to take almost all these things which are here. Then it's going to show in your research field what are all the keywords which can be used. Okay. So as I said, Scopus is pretty much easy if you know how you can use it or tell someone how to use it. That is pretty much relevant for you. And for bibliometric analysis, it's very simple. You need to check this out and you need to download it as a CSV. So when we are choosing it as a CSV, for bibliometric analysis, we need almost all these information. Why? Because we are going to make connections using bibliometric analysis of how the documents are connected, how the authors are connected, which institute they belong to, like what kind of author keywords have been used, what kind of other keywords has been used. So that's the reason people who are using Scopus for your search, you should check out all this information, and then you can download it if once you download, it's going to be produced as a CSV. So that's a small brief about Scopus over here. Do you all have any doubt at this stage, or do you want me to repeat any of the information? I would be happy to do that for you. Okay, someone has asked, does capitalization of the keywords very specific? It doesn't matter over here. It's only going to take the words as it is, the meaning of the words, rather than whether it is capitalized or it's a small word. But it would be very, very specific if you're having any kind of Latin or Greek words inside this curly brackets. Okay. So if you do not have any questions relevant to Scopus, I think I'd go to PubMed. Okay. So on the contrary to Scopus, PubMed does not need a subscription, and I guess most of you would have used PubMed, right? So now, what here, unlike Scopus, right? See, you check out the terms, which is like author, first author, second author. You have mesh terms. You have text keyword. There are a lot of only title and abstract. Unlike Scopus, this doesn't have title, abstract, and keywords. So it's better to choose all fields. See, when you're not very sure, right? Even Scopus, you can have a very, very refined search if you want to check which all the papers have this keywords listed in keywords alone. But if when you're not sure, it's always better to use all fields, right? So I already have searched a couple of things over here. So I'm going to use it for example. I'm going to use double quotes over here, right? And I'm going to search a reproductive outcome, same thing which I've shown in my example, and I'm going to search it. So over here, you can see when compared to Scopus, what you're going to see is that in PubMed, the number of results are much more the papers, because it's going to bring out all the papers which are relevant, right? Now I need to add my second category, which is like household air pollution. I'm going to search over here, and I have specific set. Now what happens is that I can combine both these queries together, but however, I have searched it separately. So I can go to advanced. Now what I can do is that search number 7 and search number 8 is where I have searched for reproductive outcomes and household air pollution, right? So I can combine both this by using a Boolean operator, and I'm going to say combine both the search. So I'm having 61 results. So when you are downloading data for your bibliometric analysis, mostly I have used only Scopus. Some people use multiple databases, bring in all the data, and take off the data which are overlapping in both the databases. For example, it's in PubMed also, in Scopus also. So we need to retain only one set, right, which is relevant to us. So we can combine the search query and get, and also we can say over here. So what you want from this results page, all the results, what you want as summary or as abstract or CSV. So generally for bibliometric analysis, we are going to download the CSV as we downloaded it again from Scopus as well. So the databases which are right now, they are all refined much. They are also going to tell us a lot of things. Here also we can see this research right from 2000, after 2010. In this particular year, there are so many number of papers which are emerging in terms of household air pollution and all this pregnancy outcome. But then what this keyword search has let us is that no matter air pollution is an emerging topic, even you put it as air pollution, there are only limited number of research which has happened on pregnancy outcomes. So it shows that it is one of the potential research areas which we can do. Or and also inside that also, when we take this data and plot it in bibliometric analysis, You can get what are the, topics which has been researched well, or what are the upcoming topics, what are the topics which are still in its preliminary stage, and all those things. So that's it for my session here. If you have any questions, I'd be happy to answer your queries. And it's not restricted to whatever I have shown over here, the usage of keywords and other things. The more better keywords you are using, you will see that instead of getting more number of papers, you are going to have very limited number of papers. From there, it's always easier to find out what you want for your research question. So that's it. If you have any questions, please type me in the chat box.
I would like to request everyone that if anyone has any question, please free to ask by raising your hand and or typing them in the chat box. But as due to the time constraint, we want to be able to revisit the concept as in the chat box. Some concept is requested to repeat. So during the session, we won't be able to revisit the concept. However, I'll share the recordings and the study material so you can review them at your convenience. So we can have a quick question and answer session as there are two more parts of the session. So uh, you can ask any question if you have. Okay, there is one question. From Sushri Nibedita Panda. How can we ensure the search terms appear within the same sentence? Example, smoking and cardiovascular disease. So, ma'am, I
You
would like to.
can use the search term within the same search itself. Like for instance, in the first line itself, you can use smoking and cardiovascular disease. Okay. But the probability of you missing out certain papers can be more, or there can be more number of papers, right? For cardiovascular, there can be alternatives as well. And also for smoking, there can be alternatives, right? So it's not the hard and fast rule that you have to categorize and only go and search. But if you categorize it, it's always better for you to have some minor changes if at all you want to make in the future or while you are searching also. Databases like PubMed and Scopus have the built-in synonym database. Okay, so Scopus as of now, Scopus is integrating AI. If you have subscription to Scopus AI, by itself also, it is giving you certain suggestions. You can always see a machine is always going to give you a lot of alternatives, but as a human, you have to take a call whether it is relevant to you or not. For that is why we have to do multiple searches. It's not that only once we have done the search, we are good to go. If you're even when you're an expert, you might tend to miss certain things. So you can use different combinations of the search keywords and try to see so that you don't miss any of those things, right? But Scopus database, they do have a good synonym database as of now, and they do cover a lot of things. I am not really sure about the PubMed database, but Scopus gives, better alternatives.
Anyone else?
Yes, if someone has asked Scopus, can Scopus help visualize bibliometric networks? Yes, it can do it if you have subscription to Scopus AI. It does. Not as extensive as your bibliometrics, as bibliometric, but however, it can give the emerging topics from how the topics are, like branching out. Those things Scopus is able to do as of now. I mean, this was not part of the session, otherwise Scopus AI, since most of you do not have Scopus itself, that's the reason I did not extend to Scopus AI. Otherwise, Scopus AI is also, it's good to go. It's doing a lot of work as of now. Okay, are there any ethical considerations? Okay. You can use ChatGPT or AI to refine your keywords because they are only keywords of what human have used. That is how that AI is knowing what are the alternate keywords, right? And while you're taking Scopus in itself, Scopus is using Copilot as of now, which is Microsoft AI, and that is how Scopus AI is also working. I don't think there are any ethical considerations for using ChatGPT or other AI to refine your keywords. Because what a human mind cannot do, AI can actually do it within seconds. Instead of you can always be smart enough to use AI to find alternative keywords of which we were also not aware of. Because in certain aspects, I am not an health expert, but I am an air pollution expert, but I might not know certain medical terms. I can use the help of AI rather than, going through a lot of papers. Or if I have less time, I think that's what I would do.
Okay, I guess we can move ahead. Um, so thank you, Dr. Priyadarshini, for providing such valuable insights through your presentation. So our next mentor is Ms. Pragyan Monalisa Sahu. She is going to tell more about searching data from bibliometric databases with appropriate search strategies, use of different software for bibliometric searches, downloading data and removing duplicates, data cleaning and merging for bibliometric analysis. So before going to this part, let me introduce Ms. Sahu. She is currently a PhD scholar from Department of Analytical and Applied Economics from Utkal University, Odisha. She has done her master from Utkal University itself in economics. Her research areas are public health, burden of disease, population aging, and healthcare, universal health coverage. So I would like to welcome Ms. Sahu.
Thank you, Dr. Ravita. Shall I share my screen? Am I audible?
Yeah, sure. Yes, you are audible.
Okay. Thank you
Uh,
for the introduction.
yes. You can share your screen now.
Yeah. Is it visible?
Yes, it is visible. Please go ahead.
So basically, I am going to handle today data download and cleaning for it to duplicate records and managing it and merging it, then uploading those data sets in different softwares. I'm trying I was listening to the session and I noticed that there are overlaps between my and Dr. Priyadarshini's session. So I'll try to avoid like skip those contents which were already covered. So I'll directly jump into those which are not covered since given the paucity of time. So basically, while we are dealing with data collection and management for bibliometric analysis, this step or stage comes at like at very end of the race. This is when you have reached to data collecting data, then managing it, cleaning it, then and going for analysis. You are at end of your journey. So we have to know, like I am before going to that, I am trying to kind of summarize what are the steps are, and briefly state what are the precautions we should take in all the steps. Like these are the different steps which we have to follow before we reach the data management or export and organization of the data, which comes the like it is before your manuscript is fully prepared or analysis. So this comes at the seventh step of uh, bibliometric analysis. Like the first step is always, as it was discussed, is defining the research question and scope. So it has been discussed earlier that you should have a, while deciding your research question, you should have a clear focus. Why clear focus? Because if you have a research question defined at a very broader reach, so that gives you, while you try to decide your keywords on the basis of that, of a research question which is very broad in its scope, then it may be that the results or the number of records you get, they might be so large that it wouldn't be feasible to handle it and analyze it within your given time frame. So, and that becomes humanly impossible. So that is why, and it is always, as we say, that it is always better, or the change or pattern is more observable or prominent when we observe at a micro unit or smaller unit. So it is always better to narrow your focus down. So you have clearly defined research questions which are not too broad. Then also you shouldn't also go to like a very niche topics, which which may give you results like a number of, while you search using such terms, you may get records which is less than 10, less than like very few records. In bibliometric analysis or any review kind of paper, it is always better that our records should stay at least above 100, because the reviews, while we submit it to journals for publications, the reviewers, they are mostly very skeptical about such papers like review papers, bibliometric analysis and meta-analysis. Even if you are doing a systematic review kind of thing, like meta-analysis, meta-synthesis, you can justify records below 100, but when it comes to like bibliometric analysis or normal thematic review, it is very hard to justify to the reviewers. So you have to fight with them during the review process. So it is always better and safe that your records should stay above 100. So then you have to choose specific topic, and if you want to like put any filters or any boundary to your research question, like any geographic boundaries like Southeast Asia, South Asia, Nordic countries, whatever your geographic boundaries you might want to incorporate in. Then a time frame, there are like you can want to want your key terms to be within a time frame, like the research on COVID, it must be after the year COVID came. So that may require you to input time frame. So that is these are the like broad things you have to keep in mind before defining a research question or your the scope of your study. Then obviously select appropriate database. Like after you have selected your research question or defined the research questions, then your research questions can say which databases you need to choose. Like the previous in the previous session, which uh, like in which it was covered how these databases like Web of Science, Scopus, Google Scholar, and all the other fields from which you can download your databases like PubMed, how what they provide you and how they differ from each other. Like if I am doing my research in health, so and with my field of research also, I have to see what circumstances I am in. Like if I want to take Web of Science and Scopus, I need to have access to it. Like not every institution may provide access to such databases, so I may stick to PubMed. So like that, you have to choose your database. After that, these are the keyword selection and development of search terms. You have to develop your keyword and develop a search terms according to what you which these are all covered in the previous session. So I would not enter much into that, but I would like to add to the previous session that the truncation and wildcards and the proximity operators, these do not work in PubMed. They work in Web of Science and Scopus, but they are not like PubMed doesn't support the truncation, wildcard, and proximity operators. So you have to keep that in mind before choosing your database and deciding your search terminology and applying it to different databases to download your records. But phrase searching, like the inverted comma one, uh, it is supported by all the databases like Scopus, Web of Science, and PubMed. I am basically going to focus on these three databases. So you are going to hear a lot of about these three. So, and another thing I would like to add that you can also refine your search by filters and criteria like publication year, document type. You can want, like, somebody is trying to do a bibliometric analysis of RCTs which have been done on like anything, any biomedical condition or whatever. So you can put any in the filter of your document type RCTs. Then subject area, if you want to focus on restrict yourself to biomedical sciences, you can restrict yourself to that. Or you want to be in social sciences, keep your focus on social sciences, then you can also put your filters according to that also. Again, this is very this step 6, and this is very this is very critical. Before you fixate a search strategy, always iterate and test search different, like trying different combinations. Because as it was mentioned in the previous session, you do not know what you are missing. It may be that by trying different combinations, you may discover something new, or you may discover some new keywords which you may like to add. So always it is better that iterate and test searches your search keywords before like fixing a final search terminology. Then the step 7, at the last step, or the last step of handling the data or deciding the database, comes exporting and organizing data. So we are going to cover that today. So basically, I am going to cover focus on three softwares: Zotero, Biosphere, and R. So when we try to do bibliometric analysis, it is always convenient and better, and it has been also widely used in bibliometric analysis is the software R software. But for certain analysis like the network analysis, uh, some in some places it has been Biosphere has been preferred. So that is why I am going to cover both Biosphere and R also, and Zotero is needed for the purpose of Biosphere. But in R, we can directly handle and directly go for the analysis part of bibliometric study. So before I show you how to like export and or manage duplicate records and merge different databases to do the analysis, I want you to keep this in mind that merging or using different databases. And for a bibliometric study, like it has been growing lately that people are using different databases, but uh, mostly those who are bibliometric experts, I have seen that, and I have all the bibliometric workshops and uh, schools I have attended. They mostly mention that it is better so to take only one database to avoid any uh, machine led errors. Because if you like your focus, if your focus is on social science, if you take Scopus, then that may suffice. The problem is that when you take multiple databases, the problem of multiple records also, or duplicate records, comes when you take multiple data sources. And the software which are available and all the codes we follow, which I am going to show you today, to handle that for duplicate records, they are effective. But there are always some errors which are beyond your the power of the human to handle it. Like if I have a record of 10,000 and 20,000, two records from two databases. One is 10,000 and another is 20,000. So while I am trying to merge it using a software like R, I'm not going to individually check each and every row of both the data files, whether the merge I have done is correct or not. And the records which we get from different databases like Web of Science and Scopus, they are the records which are provided by the journals. When the journals get indexed in the databases, the information they have provided to the journal, on the basis of that you get the data. So there may be some error. So in such case, when you take multiple databases, that error comes, which sometimes it is not easy to catch. So it is better if you have access to Scopus, then it very good. If you have access to Web of Science, very good. If you do not have access to Scopus and Web of Science, and your health or your research field remain in the field of health, then you can always go for PubMed. PubMed is the best source for health data. So it is always better to take only one database. They are huge databases. You will get sufficient records for your analysis. Keeping that in mind, so we should proceed. See, before I let me first show you how to merge. I am going to take data from three sources, basically Web of Science, Scopus, and PubMed. And then first I am trying to show you how to convert the data sets by cleaning it for so for Viewer. Then after that we'll go to R. But before that, we have to do it in Zotero. So for that, we have to have the Zotero software with us. Assuming that not all of you have the Zotero software, I am showing you where to download it. Is my screen still visible?
Yes, it's visible.
Okay. So to download Zotero, you don't have to do much. You just go to Google, type Zotero, and you will get something like this. This window will come,
Uh,
and you will have this.
Miss Mona Lisa,
Yeah,
your screen is still in the PPT mode.
PPT. Okay, that is why I was asking. Let me check. Okay. So is it visible now, the
Yes,
Zotero
yes.
window?
Now it's
Yeah.
visible.
Yeah. Okay. So just go to Google and write Zotero. You will get the first result will be your Zotero, your personal search assistant. Then go to that and you will get this red download button. Click on it. Whatever you have, like you can have it for phone also, but you downloaded for Windows. If you have Mac, I don't think it is not showing option for Mac. It should have a option. Okay, so it doesn't show an option for Mac, but it is available for Windows. So go there and download it. I already have the Zotero, the Zotero app, so I don't need to download it. Okay, so after that, how do I make this bar disappear? Like I am not able to see the. Okay.
They can
Okay.
click on the download.
Yeah.
And from download, there is other versions. There is a tab called other versions in which you can select Windows and other. You get the Windows and but downside you can see other versions. Click on that.
Okay.
So you have.
Thank you so much. So
Okay.
you got your options for Mac also. So on the basis of your whatever you have, you can download like that. So and one point to keep in mind that before managing all the records in Zotero, for that we have to download all our data set in RIS format for Zotero. Like here I am just randomly searching something. This is Scopus. This is our Scopus database, and I have chosen all. And health and near three outcome, health within three words. If it gets outcome, then it will take that into consideration. And let's see how many records we get. I think it will be pretty much pretty large record, because the search terminology is pretty broad. Okay, so it got refreshed. The page got refreshed. Okay, I don't want title abstract key. I want all. Okay, so pretty large records, but I am not going to use it. I have it saved. You use your keywords as you have been taught uh, in just format, so that you get justified number of records. So this is how you are going to like use your keywords. And you can use your filters, like time. You can put a time filter, like you can bring this backward and forward based on whatever time period you want. Subject area, document type, article reviews, book chapter, book or conference paper, whatever you are, short survey, retracted or undefined, whatever. Then source title, if you want the publication, you want to like track the publication record of a particular journal, then you can select a source title, publication stage, whether it is in final or article in press. Then select what are the keywords you want to include, but I'll suggest you avoid including it, but you can including this as a filter. But you can include this put keyword as a filter to exclude some particular keyword you want to get rid of. Like suppose adult, if I want to exclude, then I'll click on this. Then the keywords, the adult keywords work in whichever records that will be, it will get excluded. Then affiliation and all the such filters, or then language, then all such filters you can use for your search. Then going for PubMed and PubMed search, let me tell you first, when you are searching PubMed, uh, when you are searching PubMed, it is directly getting PubMed. Okay, because mine is it is logged in. Let me give me a second. When you search PubMed, do not go to like PubMed Central or like some other website. Just go to this PubMed, the first thing you get, and go to advanced. After that, you will get your advanced search window, and using that you can have your keyword search in here, because it is not it does not PubMed does not support near command, such command. So I'm just going to use, I'm just using it, health outcome. It is also very broad. The records, as you see, the number of records is very less in PubMed because of its specific focus. Then we'll go to Web of Science. Then Web of Science also, go to advanced search, then perform your search, all fields. Use Boolean operators and all that accordingly, how you have been taught. Okay. So now when you have to download it in RIS format. Right. Select all the records. Since I do not have access to Web of Science, so it will give me the option of only downloading 1,000 records. So you can keep that in mind while downloading it, and always be greedy while downloading your data from any databases. I always choose full record, because you have to do all the analysis which involves a lot of indicators. So it is always better to export full record. I am not going to export it. I have my file prepared, and it may take some time, so I'm not going to do that. And keep that in RIS format. Then for Scopus, choose all. This also will have some limitation because the records is very large. It will show me some, yeah, up to 20,000 document at a time can be downloaded. Here also, you choose everything that you get, then export. So just change this. If I change this into 20,000 record, then I'll be able to export it. I'm not going to export it. I have it. So always export in RIS format for views viewer when you want to do it in views viewer and handle the data in Zotero. For yeah, for Scopus and Web of Science, you can download it in RIS format. But for when it comes to PubMed, it doesn't give you data in RIS format. So for that, you have to go for the PubMed format data. This format, this is also supported by Zotero, so it will do the work. So Scopus and Web of Science, they are in RIS format, and the PubMed file is in uh, like PubMed format. So after that, let me show you the Zotero. Let me. Am I audible?
Yes, you are.
Okay, but I cannot see my. Window. Is the Zotero window visible?
Yes, it is.
Okay, good. So
No, it is
you
not
can see
visible.
here, it is Zotero
The
window is
Google,
not visible.
the
No,
Google
no,
page of
Zotero.
Zotero is visible, not the Zotero window.
Okay.
You minimize everything, then you can open.
Okay.
I think you reshare your screen.
Yeah, that is what I'm trying to do. Dr. Ravita, can you stop sharing from your side if that is possible?
Yes, just a minute.
Yeah. I'm not getting the, yeah. Okay, good. Okay. Can you enable the screen sharing, please?
Yeah, sure.
Okay, thank you so much.
Mm.
Okay. Yeah. So is my Zotero screen visible?
Yes, now it's visible.
Yeah. As you can see, you go to Zotero and you have to, you'll have something like this group library. In that group library, you have to create a new group, a new group, so that it will take you. One second. I'm not able to see the whole screen because of this. In 1 second. Okay. So you'll get your the option of creating a new group. By creating a new group, after that you'll have to import your files. By clicking on this group, you'll import all your files. Like I have kept it in my whatever folder I have kept, then I'll have to import them. Then this will come in this format: bibtex, RIS, and Zotero RTF format. Then click next. It will take you to the place like wherever you have saved your file. I have saved it here, views viewer. Like you can see, health. This is the PubMed file. It is in the PubMed format. This is the Web of Science file, and this is the Scopus file, and they are in RIS format. Then you have to import them, go each one by one. After importing, like I have kept them imported here. You can see all the data or records I have imported through Scopus and Web of Science and PubMed. After that, you go to duplicate items. As you can see here, you can see here all the duplicate items from this group will be visible here. And when you click on the duplicated items, like you see asthma disparities and asthma disparities, it is duplicated. So it will give you the option to merge it. So you have to manually merge everything or each duplicated item. Like I have merged it, then again beta blockers, you have to again merge it. So like that you have to merge everything. After that, when you merge everything, so your duplicate items list will be empty. What it is doing is, when suppose one record is in Web of Science and the same record is in Scopus, instead of dropping it, it is merging them into one file. Why? Or keeping only one file, it is merging both of the file into one, because there may be like some record can be a print state, and some record can be in a final state. So that is why there is a missing, like some information may get missed when we like drop only any one record. So that is why it is merging both the records into one file and keeping all the information. After that, when you do that, after deleting all the duplicate records, you can export the library. Then you have to export, it will then export all the data in you have to keep it in a RIS format only, the same format. Then you have to save it. I have it saved. You can save it anywhere. Like I'll save it here. I have it saved. I have it all. I have already have it saved. Lecture PGIMER. So you will save it in RIS format. Then after that, let me show you the views viewer window, where I can show you how to import that data. I have already imported it. While you are trying to import the Zotero data, go to create button. If you have views viewer, just go to views viewer, then click on this create option, create a map based on bibliographic data. Next, then click on read data from reference manager files, because we have the data from Zotero and it is in RIS format. So keep that for option on. Then I have put the address of my file here. After that, you'll just simply choose whatever you want to do. Like if I want to do co-authorship, see co-authorship network, and unit of analysis are authors, and I'm taking counting as numbers. So next, or this is saying that a minimum number of documents of an author. Like I'll keep it in 10, whatever. And for each of the 28 authors, the total strength, it is giving information about whatever it found in your data, and on the basis of that, it is showing you all the authors. If you want to particularly exclude any author, you can do it here. Then see, like this is how it will give you the network analysis of or co-occurrence network of, this is co-authorship network of different authors. You can to change something, you can like again do that and select some other analysis. So this is how you'll do it if you want to do it in Viosphere. Now we'll switch to R and bibliometrics. So while we were doing our analysis in Zotero, we were downloading all the records in RIS format, and for PubMed it was in PubMed format. But when we wish to do it in R or bibliometrics, we have to download the data uh, in bibtex format. So let me show you the Chrome window first. Like here. So here you can download. Here the option bibtex is also available. Like that, it is also available in Web of Science. You download it in bibtex format for R, and PubMed data is in PubMed format. After downloading it, there are multiple ways. If there are multiple ways people follow while they try to merge their data in R. So I am going to show you two ways. The first is, see, you have all your data. The The first is you have to keep all the in R, go to R, then you have to set your working directory. By setting your working directory, then you have to, and within that working directory, your all files which you have downloaded from the web should be there, or databases should be there for the software to find it easily. So I am this is the code for setting working directory. I'll share the code. This is the code. Then these are the libraries we need to install before running the analysis or cleaning the data or merging it. So one is library bibliometrics. Then another is to opening Excel files in R, because we are trying to will export this merged and clean data to an Excel file for further analysis, for bibliometric analysis. Then after that, since I have set my working directory and all my files which I downloaded, they are here. They are here in this file. So when I run the analysis, my software will easily find it. So then if I run it, this code, this is the just converting our data which is in bibtex format to a uniform format in a to a data frame. After that, it will try to merge both the data frames. Like this is my Scopus data. In this this stage, I am trying to convert only Scopus and Web of Science, because this only supports the bibtex format. When we are trying to also include PubMed with that, like we are trying to do our analysis using PubMed, Scopus, and Web of Science all, then we have to do a different approach. So I'll cover that also. So you try to convert both your Scopus and Web of Science databases into a data frame of uniform format. After that, you will run this code, which is merging and removing duplicate. Like database, give it a name, merge databases, merge DB sources, S and W, which are the names I had given to my Scopus and Web of Science, new names which I had given to the Scopus and modified Scopus and Web of Science data, which are in uniform format. Then remove duplicate formats, where when I ran my analysis, if you can see here, it removed 18 duplicate documents. There were 18 duplicated documents which were removed by the data by the software. Then you can see the dimension of the database. Here I ran the dimension, and it showed that it has 3,197 rows and 58 columns, which is pretty good data. So then again, you have to export the data which is merged and cleaned to your computer, so that you can do your bibliometric analysis further. So like you export it in Excel format with this command, write Excel SX. This is the command. It will not run if you don't have this library called open. You have to call this library first. And for library bibliometrics, since I have, you have to install the package first. Since I have the package installed, that is why I don't have to run this command. So that is why I have disabled the code. But you would have to, if you haven't earlier, you have to run this command first. Then this. Without this command will not run, and without both of this, our bibliometric analysis command, which is biblioshiny, it will not run. So you do that. You export the file in database. Like I have already done that. As you can see, my file XLSX file database is here, and you can now call upon library bibliometrics and library and biblioshiny to do your bibliometric analysis. This is library bibliometrics. Let us call biblioshiny. It will take you to the interface. Biblioshiny is like a interface which gives you the you don't have to write any codes, any commands. You just have to input the data, and it will give you all the visualizations. In here, you have to choose load bibliometric bibliometrics data, because we have already uploaded the data in R and cleaned it, merged it. So that merged it. So that is why this is not raw file. Remember one thing: if you are doing your bibliometric analysis using only one file or one database, you can always choose import raw files. So it will import the raw file, and bibliometric, this biblioshiny field will also convert the data into a uniform format, and it will by itself also handle some form of duplicated records. Then after that, you can also, if you want, go for manual using R software and any other software to handle the duplicated records by yourself also to double check. But since we are using data set from R, is my screen visible?
No, it's not visible. Like
The
the screen is blank.
Okay, since I'm switching between windows, I have multiple windows to show. That is why it is getting paused again and again. So whenever my screen doesn't move, please do inform me, because I have lots of windows open. Anyway, so is it visible now?
Yes, it's visible.
Yeah. Since we have merged the data and saved it as database file in XLSX format in my working directory, so I will choose the option after the running the R code, which is biblioshiny, which if you haven't been able to see because of your because of the screen, let me repeat it again, because the R command is very necessary. Okay, I hope the our windows visible. You have to run this. First you set the working directory, then you have to install package bibliometrics, library open xlx. Then you have to name and name the new data which are in a uniform format, then merge and clean the data, then export the data in Excel format. Then again you have to run biblioshiny, which will take you to the biblioshiny interface. After coming to biblioshiny interface, go to data. Under data, go to import or load. Under import or load, go to load bibliometrics files. And in bibliometrics files, just upload the data which you saved from R. And we saved the database file, which is in XLS format, Excel format. I'll just upload it here. Then click on the start button. It will give you the overview of the records you have, and this shows the status of information you have. Excellent shows very good information, and they are for author, document type, journal, language, publication years. And completely missing, which means you don't have data on that these indicators like cited references, science categories, you don't have, they are completely missing. And poor corresponding author information and keywords, they are poor here. So you have to, if you see this poor, then you have to maybe you have to define your keyword selection and run the search again, or see what you have chose for to download the information from the database. Keyword plus is good, DOI is good, abstract, affiliation, total citation, title, they are like these are the overall information. If you want, you can also export this data from here in Excel format. I don't think we need that here, because our data has already been cleaned, and this is used for some other purpose. I'll tell you subsequently. So after that, likewise, you can do your analysis. Like you can go for main information. So this is not what I'm going to cover today, like all the what different analysis does, but I'm just showing you overview of it. So this is the main information of the data set we have uploaded. The time period it covers is 1993 to 2024, annual scientific production, and average citation per year. 3-field plot, you have to choose the dimensions here. This is a show like a wave like plot between different indicators you have to choose. the different indicators, like references are references were poor, so information on references were poor, so we'll go for, let us go with countries, and I have chose 20 records. It will show information for 20 records. You can choose how much records you want to share. So this is how it is going to show you the three field plot, how the publication changes, the affiliation of country to author to, and indexed keywords and all that. So this is one way of doing it. And another way, when if you want also PubMed to be included here, you also want PubMed data to be here, then we have to take a different approach, because PubMed doesn't give data in BibTeX format. It has it gives data, but in that place we can use the PubMed format, but we have to take a slightly different approach. So now for that you have to install this package if basics, and call this library if basics, and you have to open Biblioshiny, call Biblioshiny, and upload all the raw files in the Biblioshiny window, the interface, and download all the Excel files, refined Excel files from Biblioshiny. Like here, if we go to import or load, import raw files, here you will give the format Web of Science, like suppose Web of Science, son number initials, no need to change that. Browse, you will browse and you will get your whatever raw data you have, like this is the raw data. You will upload it.
Your screen is right now not working, I think.
Okay. Okay, is it visible now?
Yes.
Okay. So go to Biblioshiny. First you have to download all the data in the same BibTeX and PubMed. Web of Science BibTeX, Scopus BibTeX, and PubMed in PubMed format. Then import the raw files. You have to choose raw file option, because we are importing raw files here. But whichever data set you are using, uploading first, you have to choose the database, that database only. Then browse the data. I have kept my raw file here, like WOSBOIB, which is the BibTeX file. So I have uploaded it. So now it is giving me the overview of it. Then I will export this collection in Excel format and I will save it. Like that, I will do that for all the files. For the bibliometric, all the bibliometric files like Scopus and PubMed. After doing that, I'll go to R. After doing that, you will import all the Excel files which you have converted in the Biblioshiny interface. Like you'll open the PubMed file, the Scopus file. These are the converted Excel raw files which were converted in as a Excel file in the Biblioshiny software. Then I'll upload it. After uploading all the files, then you will run this command, which is combined merge DB sources, and the name of the databases. Like I have named them Scopus, WAS, PubMed. Then remove duplicated, true, then dimension combine, and then again you will export it as like I have named it combined XLX, which is in my it is in my the working directory. You can see the file here. As you can see, let us upload this file also. Let us go to BiblioShiny. After going to BiblioShiny, just choose, go to data. In data, go to bibliometrics, load bibliometrics. If you are using the data after refining it in any reference management system or software, then you will choose the bibliometrics file. Then browse the data. I have named it combined. Then I'll load it. As you can see, this is showing the overall information. Yeah, and like that you can carry out your analysis, bibliometric analysis in using bibliometrics. I will suggest bibliometrics includes a broad range of analysis like clustering and conceptual structure, social structure, and all that. So it is way better than views viewer, because views viewer is a software which is made for a specific purpose, that is network analysis, and it hasn't been updated since when it was like developed. So it is better to use R and bibliometrics and biblioshiny interface. If you are not familiar with R, then it is very easy. You have to let me show you then how to get download R. I showed you R, but I don't think I forgot to show you how to download R. Okay, just I'll just use this window. So go to CRAN network, CRAN R download. You will get your go get your window to download R. You can download R here. I already have R, so I don't need to download it. First you download R, then go download R Studio. R Studio you will find from POSIT. Then go to R Studio, then download R Studio desktop for your desktop. It is always also available for Mac. After downloading it, just install R Studio. If you do not have R language in your laptop, then R Studio will also not work. So remember to download both R and R Studio for the analysis. Then after that, you can. It is very user friendly. You can also could do the analysis using R only, the language software. But I find R Studio to be more convenient, and it is very user friendly. You can just import or import data here, and you will easily find these are the codes for your bibliometric analysis. But whatever code or whatever analysis you are doing in R, you will easily find the codes available in GitHub, or many repositories are there where you will find your codes and commands and all that. So that was all from my side. If anybody has any question, I'd love to take them.
So you have to cover the viewer software also, or you are only for showing here the R.
No, I covered ViewsWare software by using Zotero and all that. If you want to use both ViewsWare and BiblioShiny, then you have to like do a different set of data installation and data merging and data analysis, because ViewsWare doesn't support the formats which R supports. So that is why. But I showed both, I think.
Okay.
There's
Can
one
I
question. Okay.
can I also mention here, like Mr. Mona Lisa and sorry, Mr. Miss Sahu, and I also discussed with one professor that is working at in Flipnet, Gandhinagar, in specialization in that. Particularly bibliometric analysis. He suggests for the use the analysis for single database, not try to merge, because there is a lot of the problems. So, like for example, the PubMed is given the PubMed ID, but the Scopus is not given, and due to that reason, they are facing the difficulty of the merging, and there is the lacking of the data also. So I don't
Yeah,
think
yeah, yeah. Yeah, that I mentioned. That I mentioned. It is always better to use one database. Merging makes it more complicated, and the probability of errors is also more when we try to merge different databases.
okay, thank you.
In chat box, there are two questions.
Okay.
First one is, can we clean the data in other software and not only in our software? And the second question is, any other package needed to run in R except for Bibliometrics and OpenXLS?
Yeah, you can use Zotero as I just showed. Was my screen not visible while I was showing Zotero, Miss Ravita?
It
Because I have,
was
yeah, because I just had two questions and okay. So you can, yes, you can, just I showed that you can use Zotero to clean your data. Like you can manually merge all your duplicate records and merge them. And like that, you can get rid of any duplicated records in Zotero. Then you can export the file and run it in Views Viewer. But I use it for BiblioShiny. I tend to clean the data in R only. You can also manually clean the data if you have like fewer records. In some scientists who deal with this subject, they prefer manually cleaning it for more precision than depending upon any software. I rather say, but yeah, you can use Zotero and R. And regarding the second question, any other package needed? No, you don't. You need only Bibliometrics and OpenXLS. For one is for exporting, and another is for calling the BiblioShiny interface. And for if you want to do any kind of column matching or some kind of column dropping some kind of thing, then you can also call library dplyr and all that. Again, there was another file, a library F basics, which was needed while we were trying to also merge PubMed to Scopus and Web of Science. So these three you have to keep in mind: Bibliometrics, OpenXLSX, and FBasics. Otherwise, for other analysis, you can also use dplyr also. Why there is so much difference in number of records, Scopus and PubMed? Because Scopus has a broader coverage. Like it includes all the social sciences, and it also includes conference proceedings and all the working report and all that. And the subject focus is also very broad, and PubMed subject focus is very less. And it doesn't, like, I as far as I know, it doesn't uh, give much conference proceedings, that kind of. And it also gives majorly English literatures. But Scopus, since PubMed is in USA, United States, and Scopus includes a large amount of non-English literatures, so that is why there is the difference. Is duplicate removal the only pre-processing step before analysis? Yeah, actually, if you remove the duplicates, all the that is the only like, if you want any, if you, it depends upon your purpose. If you want to after going through the raw data, if you decide to only take only journal article, to carry out your analysis, then there is an option in Zotero where you can search within your record journal, only journals, and you will export that. Then you do your analysis on the basis of that only. But I think that will further narrow it down, and uh, the scope will be much narrower, and that wouldn't be good, I don't think. So duplicate removal is the major thing you have to do before going for a bibliometric analysis, because that kind of fluctuates your analysis. So can we directly extract data from Web of Science and develop user? Yeah, sure. If you want to do that, let me show you another thing. Let me, if you want to directly download data, raw data, and import it also, you can also do visualization only one database. Like I want to download data from PubMed, I want to directly visualize it using the raw file, then you the labor isn't that much. You just have to, but for that also, even one database also may have some duplicate records. It is always better to be sure. So for that, first you have to call the Biblioshiny interface, then upload your raw file there, download the Excel format data, then remove the duplicate by running this command in R. Like I have named it randomly Scopus unique. Like I am trying to remove the duplicate from only from Scopus data. So like exclamation mark duplicated Scopus. This is the code. After running it, all if it is the probability of having a duplicate record from one database is less, but it is not zero. So all of your duplicates will be removed, and after that you can also export that data or clean data in Excel format. Then again upload it in Biblioshiny interface. Then run your analysis.
Okay, I guess everyone has cleared their doubts. Now we will move to part three of the session. Thank you, Ms. Sahu, for sharing your expertise and delivering such an informative presentation. The part three of this session will be focused on converting data from one format to another for different applications and software, tools and techniques for data format conversion, and creating a standard search strategy chart. And this will be covered by Dr. Amit. Uh, so let me introduce Dr. Amit Vasant Mahuli, who is MDS in Public Health Dentistry, Associate Professor and Head in charge of Department of Public Health Dentistry in RIMS Ranchi. Dr. Amit has completed online courses from Howard University and Stanford University on biostatistics, research methodology, clinical trials, scientific writing, bioethics. He is also a former associate professor, member ethics committee, university NAC coordinator, and curriculum design committee in NIMS University. He has published 40 articles in national and international journals. So I'll hand it over to Dr. Amit.
Yeah, very good
So,
evening,
sir.
all. A very good evening to all of you. I can see there is a quite a good number of attrition of the candidates. I don't think. Are you all ready to hear one more, or what is Dr. Ravita? Is it fine that we
Yes, yes,
continue?
it's
Yeah,
yes,
because
it's fine.
we see from 40 to only 18 are there. So, okay, anyways, will not take much time because most of the things what I was supposed to talk is already being touched or covered by the previous speakers. Rather, I could say I was enjoying both the presentations of the previous speaker, Dr. Priyadarshini and Dr. Mona Lisa. So they had such an elaborate presentation, and they took you into the details. I think uh, so to an extent that it was one point stop. Okay, the most of the things were covered because my next lecture, which was on bibliometrics and biblioshiny, which was assigned to me, is also being covered. I'm happy to know because the people, by repeated exposure reinforcement, it will help them to gain more knowledge. and will help them to understand the concepts and clear out the concept. Myself, I'm a dentist. I'm a public health dentist rather. I'm not a technical person, but still, because of my interest, I have been working in this field. I have tried to learn lot of quite of things, and in the process of it. So before I start, I request Dr. Ravita to kindly, you already made me the co-host. First, I'll run through as per my conversation with Dr. Sonu Goel the other day. He said we should be running the standard guideline for publishing bibliometric analysis. So I'll run through that before going to my topic for the day. Then I'll give you some hands-on details of what are important in what are the different kind of data, and what your final search strategy should look like, because most of the previous speakers have talked elaborate on that, on the data and all. So let me start by this. Is my screen visible to all? Is my screen visible to
Yes,
all?
yes, yes, it is visible.
So you can all see. I'll start my lecture by talking about preliminary guidelines for reporting bibliometric reviews of biomedical literature. It's called Biblio minimum requirement. This is a very good article. This article can be found on Equator. So Equator, you find a lot of guidelines for. You find Prisma guidelines. You find Strobe guidelines. So if you search any guideline that can be followed for bibliometrics, so you will find this bibliometric guideline from Strobes. So they will not go into the details. As you can see in this graph, there is a sharp rise in the number of bibliometric analysis being published. It is a part of scientometric studies which were restricted to the library science, and people used to heavily learn this in library science because they have wanted to have analysis, and it has moved on to next level with the availability of the technology. User friendly open source technologies have made it has brought a lot of importance in biomedical science. So now biomedical science are not only looking into the quality of journals, the H factor, the I10 factor, the G factor, the dominance factor, the score co-citation analysis. You also get to know which nationality is doing what kind of work, which nationality is working more, which nationality is drawing more citations, which nationality has got more funded research. So it is an eye opener for most of the policymakers. So bibliometrics, but bibliometrics as such needs to find its ground in the present scenario, because if you do a bibliometric study, and where do you classify it? I see it somewhere in the pyramid of hierarchy. I see it with systematic review. I see it with meta-analysis. In the same cadre it should be. But at present, we don't have that for bibliometrics. Bibliometrics is unclassified by most of, at least in the biomedical science, I can say it's not classified by any of the statutory bodies like DCI, Dental Council of India, or the NMC, National Medical Council. They mention about, they have given weightages to meta-analysis, they have given weightages to uh, they've given weightages to systematic review and original research, but bibliometric analysis is yet to find its way. So with this very article, just I'll share it with all of you, but I'll just want to go through the checklist of this articles, how the things should be proceeding. So I'm very happy to know that there are very quality lectures from the mentors which have been taking place, and it is opening up a lot of new avenues for each one of us in learning the things, new things, because being from a non-technical or a computer background, we are learning a lot of technical things which are very important for us. So here we can see the first is the title. It tells about identify the report as a bibliometric review in the title. Then topics. Then there has to be a structured abstract for it, and structured abstract in terms. So it is a big challenge. When I published few of my bibliometric analysis is considered to be a review article, and uh, they were not accepting a structured uh, uh, abstract for it. Rather, they wanted an unstructured abstract. I had to modify it. But bibliometric analysis can always have a structured abstract in terms of background, methods, results, and key findings and conclusions. Then you'll have the introduction and background, justification, rationale, and explanation. So what is more important here is your objectives. What objectives you draw before the start of your bibliometric analysis will hold a key for your bibliometric analysis. Why do I say this? Because your bibliometric analysis, if you are doing bibliometric analysis, can also be done for a single journal. If you want to see what kind of articles are published over a period of time, you want to see what kind of how many there are international collaborations, you want to see how many multicentric trials are done, how many funded studies are published in a particular journal. So that is one. Then there is vast, sometimes it has come to the word and the disease. You want to learn about a disease, you want to learn about a method, which centers are working more on it, and you want to learn what is the international attention to a particular topic, what are the thematic or the focus areas that are being learned on those research areas. So there is a lot. So you have to be very clear in your objectives, because your objectives will draw a lot of attention on what kind of bibliometric tools you are going to use. Because in my presentation, I'll be briefly speaking about what these tools are meant for, and I'm not going to do details because there are separate sessions planned for it, but I'll be speaking very much in brief about what these different tools are meant for, and in what format you can use them. Then search engines, finalizing your search engine search strategy, which is and time period. Obviously, the time period is very, very important, because we are dealing with a dynamic data here. The data what is being generated will not be the same tomorrow, because as our previous speaker has already highlighted on this. So but if you are mentioning the time frame from so to so date, the data whichever you have recovered has to be the same. It should be reproducible. So you are then is selecting eligibility criteria, then refinement of your data, then quality assessment and data synthesis. In results, descriptive statistic findings. Most of the as the biblioshiny and bibliometrics will give a lot of descriptive statistics in detail about what these, and there are semantic map and trends. It tells you about where the study is going, where the topics, how the topic has been growing, what are the what are the focus areas in those topics. The keywords can be checked, what keywords are being searched, and tabulation and summary findings, and discussion, summary of evidence, interpretation, strength, limitations, and conclusions. So I'll share this very article with you. So what are we doing is, there is a small exercise we were asked to do. So is this enough? Is this enough, or do we need to make uh, a very specific? Do we need to classify this bibliometric analysis, and do we need to have separate guideline for each type of bibliometric analysis? We have to think over it. So this is just to open up a few things for you, so that it will be easy to understand. Now I'll stop sharing this, and I'll come to the PPT, PowerPoint presentation, which I was supposed to start with. Okay, I guess all of you are with me. Yes.
Yes, sir. We're here.
Yes,
Yeah,
sir.
yeah. Very happy to learn at least some are active. So because see, I'm not taking much of your time. I'll finish in 10 minutes, because I think it's over burdening for people to hear for so long, and maybe you will the number is attriting furthermore. So I have been assigned three main topics: converting data from one format to other, or for different applications and softwares; tools and techniques for data format conversion; creating a standard search strategy chart. So starting with, what are the primary data formats that we come across commonly in bibliometric analysis? So when we talk of reference managing formats, we have RIS format. So we have so basically we have format in text as a plain text. This is basic format that might contain raw bibliometric data in unstructured or semi-structured form. You have comma separated values, CVS format, a widely used format for storing tabular data. Okay, so we have seen that. Then we have XML format, we have BibTeX format, we have RIS format. So then we have Microsoft Excel format. So for reference manager, basically we have RIS format. So when I say RIS, it means Research Information System format, and BibTeX and EndNote formats are for reference manager. For database export formats, we have WOS, Scopus, and PubMed formats. Citation network formats, we have GraphML and Net, and metadata standards, we have some formats. So what are we doing is basically we are handling with the metadata. So whatever metadata is there, we are trying to analyze. So one thing we have to understand here is, as I was saying in my previous lecture, objectives of your bibliometric analysis are very key in selecting the tools. Why was I saying? Because some of the tools will just give a overview or will just present how the data is, and some of the tools will go into the metrics and do the statistical analysis, and will get very interesting results. So BiblioShiny for bibliometrics from R is one such software wherein you are getting the statistical part of your data. So it is more advanced, and you have a lot of metrics in it which will give you good and enough amount of data to analyze. I feel it's more of a complete analysis that you get in BiblioShiny or the R based platform. Okay, and then the other formats are visualization softwares which will just draw graphs and which will just highlight. So converting data from one format to other format, you have different applications and softwares. Common bibliometric data formats are BibTeX. The extension is .bib. So, and the RIS format, a standard tag format developed by Research Information System, then the CVS format, then the EndNote format, and the plain text format. So core bibliometric elements that are to be included in your data. So this is the metadata what you are considering. So what data you want from one article? So you want its DOI number, you want ISN number, you want publication dates, author identifiers, you want institutional affiliations, you want citations data, you want reference lists, you want citation counts, you want citation context, and you also want to know the impact metrics like journal metrics, author metrics, article level metrics, and alternate metrics. This is the data that we expect from. I'm more speaking about the data that it is there in the different format. So when on this slide, you can very well understand why the previous speakers are being saying, and one of our mentor, Mr. Vijay Kumar, also Dr. Vijay Kumar, also had a take on it that it is very difficult to merge data when we are doing bibliometric analysis. The challenge is not every form of data you extract from these databases will have all of these. So there will be a lot of variety, there will be a lot of variation in this. So merging becomes a big challenge, and there can be error message. And whenever you are handling large set of data, there can be issues with data loss. So you will have to really check what is the amount of data you have you tried to merge, and whether that merge has successfully done, because there are many errors. Because in one of the previous studies I was trying to merge, so there were many errors in terms of data merger. There was loss of data. So that is one of the thing that you have to be really aware of. So bibliometrics, what are the formats that are accepted in bibliometric R based? You in from Scopus it is bib format. If you are exporting from Web of Science, it is bib or text format. In PubMed it is text format. Cochrane it is bib format. And in Dimension, which is a very good tool, if time permits, I'll just show you about, I'll tell you about Dimensions. It is a AI based database that will give you instant insights of lot of things that you're looking for. So then there are BiblioShiny is a web-based interface, same as our Bibliometrics data form accepted are almost similar, and it allows us to perform analysis and visualization interactively without our coding skills. So one of the main challenges when I started learning about this is in Bibliometrics, I had to write the codes. It was a big challenge for me, being from a biomedical background, because even a small mistake in a comma or a colon, or even a spell or a uppercase or lowercase would find an error as a result. So that was the biggest challenge. So now with BiblioShiny, it is all interface based. Like you on a click of a tab, you can get your results. So that has made things quite easy. Then there is SiteSpace. There is one more tool which uses data from Web of Science in text form, Scopus, CVS, RIS form, PubMed text format, Crossref XML format. Then there is BibExcel, one more tool from in which the data formats are accepted in text format, CVS, and RIS formats. So this is the summary table of Bibliometrics accepted data form and its main purpose. So Bibliometrics accepted data forms bib, text, and CVS. Uh, Science mapping, statistical analysis is the main stay. Whereas BiblioShiny, you have web-based interface for bibliometrics. You can see site space. Likewise, VOS viewer network visualization, WOS viewer is more appropriate to be used. Then the other forms which we are not talking about, but still I've given you, tried to compile this through the table, summary table. Then we have one conversion tool. So whenever you want to convert from one data to other, this challenge you generally face when you are using uh, bibliometric analysis through different tools. You might find an error. Initially, there was no much way in which you could have converted data format from bib to CVS to RIS to Excel or so. So what is the best way? There is some online tool called from PaperPile, which is one or two conversions are free, but most of them are paid. But we need only one or two conversions, so we can go and convert our files through this online uh, bibex.com from one format to the other format. You can convert from bibex to CSV or RIS or other formats. So this is one option what we have. So likewise, you have other tools online, that coolutils.com, wherein again there is a one or two files they can freely convert from RIS format to other format. So data conversion softwares, VOS data converter is there. It is inbuilt in the VOS data. Zotero is there, and EndNote is there. EndNote is paid software, so we're not going to talk about it. I thought of explaining about Zotero, but let's see. But the Zotero is very well covered in the previous lecture. That's what I told you. Most of the things what I wanted to cover is already been done. But I'll give you a hands-on at the end in 5 minutes about Zotero. How we just learn about how to upload and convert the data from one format to other in the Zotero. That's it. We are not going to learn about the duplicates, merger, and all that part, which has already been covered. I'll just tell you the basics of Zotero. So before going to the next topic which I was given, let's go back and learn a few things about Zotero. So for that,
Hello.
yeah, one sec. I'm sharing
Okay.
it.
Okay. I thought some technical issues there, so I.
Yeah. No. So this is the new updated version of Zotero. I think it's almost similar to what was being showed to you. Is it visible to all of you?
Yes, it's visible.
Yeah. This is the new version of Zotero. Then I just wanted to tell you about. So I already have a data set. If you want to upload any data set, you can go to the file and you can say import data set. From import, you can say, see, the data set is acceptable in the format of BibTeX, RIS, Zotero, RDF, and etc. So you can just click on the bibliometrics and select any one of the sorry, even let's take a bit. So we can import it. So it'll take some time. Before that, I have already imported the data over here. So I have imported all my data in Zotero. So first is there is, if you want to do the data cleaning and you want to check what kind of data is there. So click on one of the titles here. Click on one of the titles. You will, on the right hand side, you will get to know what all data is being there. You can see the title of the study. You can see the item type, that is journal article. You can see authors. You can see all the authors, how many authors they have been listed, publication, from where it is done, volume, issue, page, date. Then you can also see volume abbreviation. You can see language. You can see ISN number. You can see copyrights, reserves, and date modified, and even the abstract of the journals. And you can also see what keywords have been tagged. Okay, you can, if you want to see what was the data that is available for us, so you can see the keywords that is tagged from this very article are anti-infective agents, chronic periodontitis, diabetes mellitus, antimicrobial peptides, dental plaque or indices, right? So I'm just telling you all this because whenever you want to you import the data, you need to check at least randomly whether the data tags that you are selecting for bibliometrics are being met or not. Sometimes the data, if it is incompletely exported, so you will not be able to run the bibliometric analysis. So you need to, this is called data cleaning or data uh, understanding your own data. So once you are done with this and you want to convert, so you want to convert this into a bib format. So I'll go to the file again. There is an issue with the file is not being open. Let me. Okay, there is we are finding some issue with the Zotero application here. So ideally, when we click on this file, there is an export tab that comes up. The software has presently not functioning properly because reasons not known to me. So once you click the export button, so you can select what format you want to. You can, there is multiple formats that it shows up. You can select the format from bib to RIS format, bib to CVS format. So you can select multiple formats and you can very well use it. So that is from the Zotero part. So there are certain tricks whenever a previous our speaker was saying, like sometimes what problems we face is we have a limitation of file download from Web of Science. Like we can only download 500 at a time or 1000 at a time. So if your total search is more than 1000, what we do, how do we combine that? So that can be combined you using simple methods by downloading both the files and creating a text file first, and copy the data from both the files one after the other, and rename the text file from .txt to .bib. So that is as simple as that. So you can very well do that. Before going to that, we will go to the last part of our presentation. Okay, the last part is creating a standard search uh, chart. So you have to be very well versed with these formats. The main purpose of the lecture was to understand what are the different formats in PubMed. Basically, your extracts are in text format, TXT format, which can be easily converted to bib format just by cutting and copying it in a text file and renaming it as BIB format. You can easily convert it to that, or you can use any of the online tools I told, or you can use the Zotero file from converting from one format to the other format, which will make easy for you in certain tools which expect a certain kind of formats. So the last part of the presentation is creating a standard search strategy chart. So first is define your, it's already been covered, I'll go very brief. Define your research question and objectives. Clearly define the research question and objectives of your bibliometric analysis. Make sure your search terminologies are not very vague. So you saw like how you can use the words into parentheses. You can saw how you can put the words into flower brackets. The process is called nesting. By adding in search strategy, you use Boolean operators like and, or, and not, and you also put it into parentheses. You also use flower brackets, and you use the flower bracket and you put a Boolean operator, and it will give you a effective search. So the main idea is to boil down to your specific, as specific your research question is, the better are the results. The more vague it is, the more it's like the one I'm choosing, artificial intelligence in healthcare. So this is a very vague topic. I have to do, obviously, I have to take two terminologies, artificial intelligence and healthcare. So this is a very vague topic. Maybe I'll get my results in 15,000, 20,000 or something like that. So when it will be difficult for any tool or software data handling, and it will not be precise. Your results will not give you what it is intended to. So what is the best way? Like artificial intelligence, you have to go and try and check if artificial intelligence is a mesh terminologies. Mesh terminologies, medical subheadings will have automatic, there is something known as automatic explosion. That means under artificial intelligence, you will have terminologies like machine learning, you will have terminologies like generative AI, you will have terminologies like algorithms, you will have terminologies like data intelligence. So all you have to check whether the term you have chosen as your mesh term has inclusion of all these terms. If you have all these terms in that mesh term, then you can avoid using synonyms. But if you have to use synonyms, then you have to be very clear that mesh terms and the topics covered under mesh terms, these synonyms are not part of that mesh term. Then you can go ahead and add those as synonyms, and you can formulate your. And healthcare is a very broad topic. So what are you trying to learn about? You are trying to learn about diagnosis, you are trying to learn about the treatment aspect, you are to try to learn about public health, you are trying to learn about, or any specialty in particular. So it's better to choose and narrow down your searches so that you can formulate an effective search strategy. List the main words relevant to your topic, generate synonyms and related terms for each keyword. This will include broader and narrower terms. Then spelling variations can be taken, right? It's like synonyms like machine learning, deep learning, health informatics, health technology. So developing your search with choosing right Boolean operators, narrow the search by combining different concepts, or broaden the search to include synonyms and related terms, excludes unwanted terms. Example of string, like one I have done here, artificial intelligence or AI or machine learning or deep learning or large language models. So there is a lot of synonyms that you can, and truncations, as it is already covered, using a asterisk, like it can be health asterisk. So anything related comes after health, healthcare, all things will be searched. Wildcards. So set filters and limits. This is very use. First, use filters to restrict search results. Time period is a must. You have to mention the time period from which time to which time the search has taken place, because it will help reproducibility of your data. Then documents chosen, you have to select, you have to be very, you should have clarity on what documents you choose. You are choosing only articles, reviews, conference papers, or patents, or all form of books and other forms. So document, what type of document you choose has to be specified. Then limit language, if necessary, you want to limit, have language limitations, you have to name it in your search strategy. Subject and area, for multidisciplinary databases, restrict to relevant subject. Like if you are searching in biomedical science and you don't want studies which are listed in say engineering or other fields, so you can just select medical science, dental science, nursing science, so related in your subject area, so that you will have your articles extracted as per your subject, what you are looking for. Then article and review, publication year, document type, and language are to be chosen. Then choose appropriate databases. See, while talking of databases, Web of Science uh, is one of the database which is so largely, there are many studies which have taken place. There are articles published on which databases are more appropriate, or which databases are very comprehensive in nature in biomedical science. When we talk of Web of Science, Scopus, so Scopus is one database which will give maximum reach, because most of the articles which are the PubMed indexed are also indexed in Scopus. And there are certain more uh, journals which are indexed in Scopus but not in PubMed. So Scopus is much a wider database as compared, but the quality database, if we speak of, it is Web of Science. Web of Science will give you more quality data, quality journals, and only those journals which maintain a certain high quality are indexed in Web of Science. But PubMed, you will have a complete, thorough outreach of all databases, or good quality journals in biomedical research. So you can use these as optimize your bibliometric analysis software. Then certain bibliometric software tools, you have to check what all fields you are choosing. Generally, it is advisable to choose all the fields like author, title, journal, keywords, citation. Export your search results in a compatible format like CVS, RIS, bib format. Then so choose appropriate softwares. So you can not necessarily, you have to use one software. If you want to have more visualization, you can use multiple softwares to bring out the best for your bibliometric analysis. And that's the way to go about it. Then this is the search strategy table. So finally, you should have a search strategy, or how you exactly carried out the search, what filters you used, what time frame you considered, what document type of document you have used, what language you have considered, what subject area have you chosen, and what databases have you considered. If you're not considering all the databases, it is wise, as said by many, to consider one single database wherein you can have ample of data for analysis. So this is one table I have tried to, hopefully we'll be sharing our presentations with you. So this is one table wherein I have tried to compile alignment of research objectives with selection of bibliometric tools. So what is the primary function of WAS? Like you can see over here, if I project this, what is the primary function of VOS player, in what data formats it is available, what key visualizations you can make, and what is the unique feature. So this very slide can help you select the right kind of bibliometric tool. I think most of the bibliometric tools what I mentioned over here, at least the commonly used one, are being discussed in this platform. and I'm very happy, and I thank Dr. Sonu Goyal, Dr. And his team, Dr. Ravita here, who are working very hard to bring in such a kind of program. And if there are any questions, I'm happy to take. Thank you all.
Thank you, Dr. Amit, for delivering such a comprehensive and informative session. We truly appreciate your time and expertise.
Yeah,
So now, if anyone has any question, please feel free to ask.
I
Meanwhile,
think
I
no
would
one,
like to announce.
I think no one has the courage left to ask any questions.
Sir,
Uh,
sir,
yeah,
yeah,
please.
sir, thanks a lot for a very informative thought. Your experience speaks a lot. So, my question to you is, like you told us, Scopus is one, like sorry, Web of Science is out of the three, which maintains, I mean, which has good quality journals. So,
Hmm.
like, if we are looking at just the, like, of course, it depends on the objectives which we have chosen for a bibliometric analysis. Suppose
Hmm.
we are trying to find the trends, then the
Hmm.
quality of more than quality, I think, I mean, my question is, more than the quality, then quantity will be necessary. Then we need to choose, say,
Yeah,
PubMed or.
there is one small, once you get working with the bibliometric analysis and you get a little expertise in it, it becomes so easy to check with multiple databases. So necessarily, what is the bottleneck we are having here? What is the red flag that we are having a problem with data merging, right?
Yes, sir. Yes.
They say that we are having a problem with data merging. So why can't we do just take up data from PubMed, data from Scopus, Web of Science, run it separately in the softwares, and give a comprehensive result in a table, so that what you're doing is you are including all the data, and you're trying to draw some commonalities between them, and then you are trying to conclude. That is one option you have whenever you are in doubt that you cannot the data merging is such a big problem. So you can individually run through, because when we get used to bibliometrics, it hardly takes half an hour to 1 hour to run through these softwares. It is not a rocket science. So when you have
Okay.
this, all you can do is you can have analysis from multiple databases and see what lines are common and what is difference, and you can very well debate in your discussion, like which database yields more results in form of trends, in form of authorship, and is there a match between all this, and you can very well debate, and it can be more comprehensive with less limitations.
Okay. Okay, sir. Thank you. I.
Anyone else? Okay,
I think,
meanwhile, I would like to announce that our next session will focus on writing the methodology section and is scheduled on 2nd of December. As we move into this methodological part, I would like to remind all the participants that the deadline for uploading your introduction section was 23rd of November. However, not all the teams have submitted their deliverables yet. Please ensure that all the pending work is uploaded promptly to stay on track and avoid backlogs. So, one more thing, for mentors are requested to share the study material if there is any. You can upload on Google Drive directly on the respective session name, or can share in the group also, so that we can share it with the mentees.
yeah.
So if anyone else has any question, please ask. I don't think there is any
Yeah.
question.
Thank
So,
you.
okay, a big thank you as well, all the mentors who guided us throughout today's discussions and activities. So your support and insights are invaluable to the success of this program. And looking forward to seeing everyone actively engaged in the upcoming sessions also. So thank you so much to all of you.
Thank
Um,
you. Thank you, Ravita.
okay, now we can end, I guess.
Yeah, yeah. Thank you. Thank you.
So, okay, thank you so much, everyone, and have a good time ahead.